Hi guys, just a quick nighttime dumpster dive. Look what I scored. Look at this. It is a Samsung flat screen TV. Haven't scored one of these. Let's quick, before anyone sees, let's get it back up to the lab. Check it out. What a Bobby Dazzler. Look at this. I've never found an LCD this big in the dumpster before. As you've seen previously, I've found a couple of plasma TVs because, well, you know, plasma TVs, they go to the plasma graveyard. They die pretty early. They get really hot. They're really, really heavy. Like the last one was like 50 kilos. This one, it's beauty. Look at it. Unbelievable. Samsung 46-inch LCD TV. Sure, 2009 vintage, so it is about 6 years old or thereabouts. Well, the model is. I don't know when it was actually manufactured, but the model comes from about 2009, but still nice, thin, sexy LCD. Look at that. Woo! What a ripper. And, well, let's power it up, see if it works. I doubt it, because nobody's going to throw out a beautiful glass surround sort of, you know, this must have been like state of the art at the time, 2009. People, anyone would happily have this in their home now. No, pretty much no one, no matter how picky they are. So it's, you know, it's fantastic. So odds are it's probably not going to work. I only give it like 10% chance of working, I reckon. So fingers crossed. And there's the model number for those playing along at home, 170 watts. Well, you know, that's nominal, whatever it is. So, you know, it's not a huge power hog like the plasma TVs are. Now, one of the most interesting things, though, is this on the back. Check it out. It's I've taken the panel off here. It just screwed in. It doesn't have your standard IEC power connector. It's somebody's gone and chopped the wires off here. Somebody's actually stripped them too. Like they haven't just gone chopped. They've actually cut into it and stripped these two wires. This is basically exactly how I found it. So has somebody maybe like powered it up down at the dumpster or wherever, and they've, you know, went, oh yeah, it still doesn't work. Okay, we'll toss it. So yeah, you know, the likelihood of it actually working straight off the bat, very, very low. But I've never seen that before. That's held in with clips, and it actually goes straight onto the power supply PCB inside here. Never ever seen that. I mean, I don't know what the deal is. A fixed power cord? Geez, haven't seen that since the days of, like, you know, CRT TVs. And even though it's about 6-year-old model, it's still got a full complement, 4 HDMI inputs. It's got PC input as well. It apparently has a digital tuner built in, beauty. Not one of those crusty old analog ones. It's got optical, USB, and there's a little service port up the top there as well. But unfortunately, I couldn't find any remote for it. Pro dumpster diving tip: if you find a TV like this or any bit of AV gear in the dumpster, then have a good look around for the remote control, because people will typically toss out the remote control with it. Wasn't that lucky this time. Sorry about the exposure on this video. It's really hard to get good video when you've got like a mostly solid black object like this. First thing I'm going to do is just measure these, make sure nothing's a dead short. So there we go, 200, I won't touch it. There we go. What is it? Yeah, well, it's open. So that was my fingers there. Actually, I think this might be an ideal opportunity to use these Inventables solder sleeves that I got. They sent this into the mailbag last time. I actually forgot to mention them. Sorry about that. So thanks for sending these in. What they are is little, I'll show you the big one. The huge one, they're little heat shrink sleeves, but they've got a ring of solder in the middle like that. So you just put your wires in there and then you heat shrink the whole thing down, and bingo, it actually solders them as well as heat shrinks them and insulates them. So I've got 4 different sizes in here, right down to these real tiny ones. I think maybe need something in the middle. This should do the business for those mains wiring. So yeah, let's give it a whirl. And perfect for this sort of thing where we've got a chopped off mains cord that's fixed into the thing, and we need to rejoin it. All right, I haven't actually checked. I don't know what temperature these things melt at. Could have a low temperature solder in there, but I'll set my heat gun to 200 and let's have a look. Here we go. Come on. Ah, wire fell out. Oh, hold the wire. All right, let's try that again. So this is 200. Of course, the heat shrink is shrinking, but it's all about the solder. No, it's not going to do the business. Going to have to up it. Actually, I just checked the website and it doesn't actually give you a temperature on there that I could find. Anyway, I've upped it to 250. And by the way, those little red rings in there, they're actually glue. So it actually insulates solders and also waterproofs in the one operation. So that's pretty groovy. Anyway, now got it to 250. Come on. You can do it. You can solder. Oh, come on. Still doesn't like it. 280 now. Come on, you've got to melt on me. Come on. Quicker just to use an iron. No, I'm sure you've got to get used to it. Once you get used to it, probably work a treat, but... Okay, 315. Got a pretty concentrated nozzle on this thing. And it's still not melting and taking to the wires. I know the heat has to get through the plastic, but geez. There we go. I think it's melted on one of the wires. I think it's melted. I think we're getting close. This is taking forever. It's just not wicking up that second wire. Now, I'm pretty sure it's done now. Like, I expected it to, like, wick right up the wires. So, okay, even though they don't tell you to do this, I've actually crimped this second one a little bit. And we'll see what happens. Here we go. Just so it's like making contact. It's actually touching first. So that the solder's physically touching the wires rather than, you know, it could just be sitting loosey-goosey inside there. And, no, still at 300. Okay, here we go, 330 now. See, it's just not wicking up those wires at all. This is getting rather frustrating. Okay, third time lucky maybe. I've set it to like 380 now. In fact, the temperature 385, sorry. And there we go. Yeah, I got some half reasonable flow on the others. But, you know, like, does this thing have flux? There we go, it's flowing. It's flowing, it's like, yeah, you can see it wicking now. That's what you want to see. You want to see it wicking. And there we go, forming some big blob now. Beauty. Happy with that. Win for a change. So I'm not the least bit impressed by those at all. It's almost as if, like, the solder doesn't contain any proper flux in it that, you know, can clean the wires and take. So I don't know what the deal is there. It's supposed to be, it actually says on the page they're actually low temperature and low melting point solder, but geez, I had to set it up so far and I had to take so long to melt these damn things, and it didn't even do a nice, good job. So I don't know. More experimentation required. Verdict's still out on those. Okay, here we go, the moment of truth. We're going to power it on. I've measured the pins and I can just see a little bit of flicker on the ohms range as it charges up the suppression caps in there. So there's something at least. So let's give it a whirl. Here we go. Nothing. Nothing. It's supposed to be the controls down here. Oh, here we go. There's the power button. Oh. Hey, it's flashing. Okay. Oh, holy crap. It wouldn't do that noise. You heard it. It wouldn't, now the LED's not flashing anymore, it wouldn't do that noise unless it, that's coming. Oh, check video. Are you kidding me? Wow. We have a winner. Beauty. What a Bobby Dazzler. We have a winner. Although something's, it looks very... No, it doesn't look that great. Sorry about the glare on the screen. It's practically like a mirror screen. Check signal cable. Nah, but it's the processor's working. The screen's working, but there seems to be some lines in here. It doesn't look fantastic. I hope it's not the panel. My hope was that if it was failed, it'd just be the caps, of course. But no. Oh, look, we've got some ghost in. Something else is weird. Something else weird. Oh, no, it came good and then it ghosted. That's weird. That's weird. Anyway, I was hoping to just be some dried out caps in the power supply, of course. See, there it is. See, you can see that. So maybe, like, it could still be that. But all the digital stuff's still working. So that is a weird fault. Wow. And if I get my polarizing filter on this thing, I can actually make the screen disappear. Look at that. That's me. I'm adjusting my polarizing ring in there. And I can actually make, if I get it exactly the same angle, of course, with the LCD polarization in there, bam, the screen disappears and it comes back. Neat, but it doesn't get rid of the glare, unfortunately. Bingo, there we go. Oh, look at that. I just turned the brightness up and look at all this. So, damn, is it the panel? I was hoping to just be a simple dried out cap power supply, but I don't like it. Still, let's take it apart and see if there's anything obvious. I mean, it could still be something to do with the power supply, which is then upsetting some of the vertical drivers, like, the column drivers or whatever, but I don't know. That looks pretty awful. Aww. All right, let's crack it open and see what's what. All right, I think I got most of the screws out. Let's see what we can do. There is one over here that seems to be threaded or something, so I'm not sure what the go is there. Might have to take this off and just put a bit of force on that and undo that at the same time. Excuse me, I need like 4 hands. Here we go, I finally got the stripped screw out and ta-da! We are in like Flynn. Beauty. Now if we have a look at the main power supply board here, you can see how completely different it is to plasma TV technology. You know how in the plasma we saw massive boards in there, multiple ones, the high voltage driver for the plasma section and all the digital stuff had really big, like high caps on the thing, big monster ones. There's basically not much of that here at all. And here's where our mains enders down there. That's that connector that we saw on the back before with the wire going in. It's got fuse protection. That's a HRC type down there. We've got some MOV protection here. We've got our requisite suppression caps. We've got our common mode chokes here. So that's all nice. We've got our high voltage mains input caps. I can actually zoom into that. There we go. That shows you a bit more detail. Look at that. We've got these radial ones just bent on the side. There's a cutout in the board in there. They do that to get the extra low profile. If they actually just laid these flat on the board, this TV would be too thick, and that's what they're trying to do. They're trying to get a real slimline design here, so they've had to put a cutout in the board under there to fit those caps in. Brilliant. Another brilliant thing, look, they've got these relays in here. They had to use fairly big ass relays here, but they actually, to get the profile that they wanted, they actually mounted them on right angle boards. Look at that. Brilliant. So that's how they get the profile right down. And everything else, this transformer over here we go. Here's the main switching transformer. Look, that's once again a cutout in there, and the thing is really embedded right down under the board. There's an insulating, looks like there's an insulating sleeve down on the bottom there. And by the way, on top of this whole board here, on the back side of the case of a big insulating sheet, because the metal, the back metal plate actually comes down and almost practically touches all of this. So it's got to have a big insulating sheet on it just so you don't short anything out to the case. We've got another transformer under there as well. That's got a plate on top. Is that for some shielding or maybe to get some heat out to the back panel? Perhaps, not entirely sure. Anyway, that's got an insulator on it as well. And these are our output power transistors. So this is all of our primary side over here. And then our secondary side over this. Please excuse, I'm not getting the best angle here to actually shoot all this and the best light and everything else. It's just not working that great. This thing's so huge. I've got the thing upside down, and anyway, hard to fit on the bench here. And these are our output filter caps. So look, there's not many of them. They're not that big because this does not require a lot of power at all. So let's take a closer look at those. Samyang, there we go. Not exactly the best. 105 degrees C rated though, but geez, yeah, there's no nice Nippon Chemicon or Panasonics in here. But the good or bad news, I guess, because it would have been an easy fix, is that there's no bulges in the end of these caps. I won't show you all of them, but there's no bulges, there's no leaks, nothing. Same with the 450 volt mains input caps as well. So nothing obvious there at all. Damn it. You might be wondering what this section here is, or you might have thought initially, if you're not too familiar with modern LED TVs, that this is a CFL driver, a cold cathode driver for the backlight, but it's not. These are low voltage LED drivers. There's actually 6 separate channels here. There's 6 pairs coming out and wires going down into the case. These are actually, because this is a LED backlight TV, and which was probably state of the art back in 2009. So they're all on the low side here. You can tell by this big divider here, and then we've got a suppression cap between the primary and secondary here. So this is all low voltage stuff, low voltage LED drivers. There we go. We've got ourselves a couple of transistors in there. And that's just a constant current, 6-channel constant current driver for the LED backlight. I don't know, it might be like an amp a pop or something. Who knows? And this other heatsink down here, if you didn't notice the big 4 leads on there, well, that's obviously a diode pack. Once again, that's our bridge rectifier. So our mains input comes straight through here, through the fusing and the protection. Common mode chokes for the filtering. Then it's and then it goes through the rectifier and then filter on the output here. Is that a big-ass common mode choke in there? Anyway, recessed into the board right again. They're really going to town getting this height profile down. This other heatsink just got some switching transistors, and these ones over here as well. And then we've got 2 speakers on the back here. The reason it's this big, this is just like a big acoustic port just to get the extra low-frequency bass performance. And then we've got ourselves the main digital board. Nothing doing here, but we do have some rather unusual looking heat sinks stuck on the top. That'd be using thermal adhesive on there. But yeah, there's not much. It's all basically just one huge single chip solution with, that's a Realtek Ethernet interface by the looks of it. We've got our digital tuner over here, and nothing much happening at all. Got our HDMI driver chip. Nothing really doing on there whatsoever. As I've seen typical, and I've showed before, it's got a dip SMD arrow here to show you that the board travels through the solder wave that way. So any through-hole stuff like this module down here and, maybe a connector or 2 or something, through-hole is just pass through the wave soldering process. So that's just an arrow for the production people to tell them which way it goes through. And we've got ourselves a secret squirrel switch in there. Don't know what that's doing. Is that some sort of secret squirrel reset? So there's virtually a 0% chance there being anything wrong with this board, because you've got the main processor under here, and if that wasn't working, you wouldn't get any of your menu stuff or anything like that. Nothing at all to do with what we're seeing here. But we do care about the output. Where it goes is flat flex going over here down to our LCD panel driver, which looks like quite a substantial board under here. So if there's going to be any failure in the column drivers or whatever, like we saw, then it's most likely to be under here if it's not a power supply related issue here. But it's fairly easy just to measure the ripple on the output of the power supplies here. Huge, big custom. What was that? WiseView ASIC. Never heard of them. I don't know what that one is. Anyway, this is the memory for this chipset here, obviously. And there's actually some, what looks like some heatsink blocks on the back, which actually went down and actually pressed onto these chips. You might be able to see some, is that some... Yeah, a little bit of grease in there, a bit of thermal grease. Maybe there's not much on that one. But yeah, there's a block in there for these 2 memory chips and a block in there for that. Curiously, there's not a heatsink block for this one, though. And there's that chipset for those playing along at home. And the other one over here, Don't know what that one is either. Alright, there we go. Samsung branded, so that's probably, you know, Samsung are huge. So yeah, they've rolled their own ASICs for this, most likely. And just like the other digital board, I don't see much that can go wrong on here, but there could be, because we're getting like column failures and other like graphical failures. So, you know, what I'm going to do is I'm going to reseat these flat flex connectors down here. Just going to, unprise them, just check them out and, you know, reseat them. You know, unlikely to be a bad contact, but you never know. You know, there could be like a BGA failure under this, a heat stress, longevity-induced failure. So that's a possibility, to try and repair one of these, pain in the arse. You might try and reflow it, if you determine the cause of the fault to be this board, or maybe you can just get a spare board from somewhere or something like that. These fuses on the input here aren't going to be blowing. No problems there. We've got some tantalum caps on there, but there's probably nothing doing. But as a matter of course, you would go in and you'd measure the rail just to make sure it's okay. Make sure there's no ripple on it. And just a reminder, if you are going to go probing around on the main power supply board here, safety first, make sure you discharge the main filter caps over here. They should already be discharged, should have bleeder resistors on them, but you can actually use, this is a good function for the auto check, the low impedance ghost voltage function of a multimeter, for example. So we can get in there and probe that. Here we go, and let's have a look. And you can see that it's actually not reading a voltage, it's automatically switched to ohms, mega ohms. There we go. So there's actually, if there was a voltage there, it would actually display it. So there's not, so that's safe. And we'll just measure some voltages on the DC output here. We'll just check for ripple. You don't actually need an oscilloscope to check for ripple. You can just put your meter to AC mode, of course, just to measure the ripple. So DC and AC. I've got a dual readout meter here, the U1272A, just so we can actually display AC and volts DC at the same time. So if we get in there and probe this sucker, I don't know which one's what. I don't think they're labelled. No, I don't think they are labelled at all. So that's rather annoying. Which one? Doesn't really matter. Here we go. 5.3, 10 millivolts of ripple, bugger all. 5.3, good enough. They probably tweak that up to, above the 5.25, but good enough. What we really care about is that there's no real ripple on there, so we'll do this other cap here. What's this one? That's 5.3 as well. There's bugger all ripple on that. What's this puppy here? 5.3 again. Oh, this is getting boring. Where's the 3.3 volt rail? Oh, 12, 12.8. There's still bugger all ripple there, 26 millivolts. So it's not something we're going to worry about. Was that positive 12? This one's negative, not sure around. I think I've got my probes around the wrong way. Doesn't matter. Just checking for ripple. 12, no, 46 millivolts, no problems at all. There's no 3.3 volt output on that one. They must be doing local voltage regulation on the boards. Let's measure these ones here. We're over on our output display board now, actually. 15 volts, that's unusual. That's not something I expected to see on an output panel driver. Yep, 15 volts. Okay, so that must be a step-up converter, I would presume. I finally found a logic level one. Here we go. Down here, 1.8 volts with, bugger all ripple, of course. That's 1.8 volt core voltage for this main processor, no doubt. Another logic level, 1.8 volts over here again. Once again, there's no ripple, everything's fine. That'd be another core supply for one of the main ASICs under here. And there's a lot of people who might say, oh, replace these Sangyang caps and things like that. But no, I don't think we need to do that because I'm not measuring any ripple. The rails seem fine. Everything I'm measuring seems fine. And like I said, these are all digital, like low-level digital stuff. Dry joint BGA under one of these, perhaps, maybe I'll just reseat these connectors under here, but I don't know. That's clutching at straws. Or if there's a panel, if the panel itself, down in here, I'm not going to take the whole thing apart. I think I've done that in previous videos, but there's going to be likely be chip on flex drivers down right across the panel like this. It could be some of those. So if it's the actual panel itself which has failed, then you got Buckley's chance of repairing it. Most likely, you might have to find a surplus actual panel somewhere. So yeah, it's not looking promising. Please excuse the crudity of this shot. I'm lying on my side under the bench where I've got it propped up against very low shutter speed so that it doesn't flicker, and it's got a built-in test photo / test pattern, and well, you bet the problem still exists with this test photo. You can see those lines and the horizontal ones as well. There's actually horizontal each, like, you know, second or third line or something is just gone. It's horrible. Absolutely horrible. Gotta be the panel driver, T-con board, something like that. So I'm really beginning to expect this puppy here, which is the control board. It's what's called a T-con board, or a timing control display board. So a similar sort of T-con type board between the main digital processor and the actual panel itself. And as I said, there might be extra drivers up on the flat flex panel and stuff like that. But this is the main timing / display board for the thing. And you might think that this sucker here is the part number, but it's not. It's really annoying. These Samsung boards, really quite annoying. This is not the part number. To get the part number for this thing, neither is this. Only part of this is the part number. You have to ignore that K on the front. You've got to look for the 2853 and then an extra letter there. So 2853C, sometimes it's 5 numbers, but in this case, if there's not 5 numbers, then you just add on a 0, and ta-da, this is the part number. So it's 02853C. You've got to add an LJ94 dash on the front of that, and bingo, that is our part number for this particular board. Now, I had a quick look on eBay, and yeah, you can buy these things, you know, $80 secondhand or something like that. You know, I only suspected, don't know yet. Next stop is to freeze these two here and see if there's any dry joints underneath, any sort of thermal issues at all. So please excuse the upside downness of this and the flicker. I've only got a fast shutter speed here. Got our freezer spray. You can also use duster spray if you don't have freezer spray. Just turn it upside down, but this is proper freezer spray. So I'm going to go in there. Here we go. Tongue at the right angle. That's that smaller chip. Anything? Anything? Bigger one? Anything coming good? No? Looks the same, does it? It's hard to tell. Yeah. Still dodgy as. Damn it. Try that again. I've got a slower shutter speed now. You can see the blur on that. Alright, let's try it again. That's the big chip. Woo! Frosty, I mean. There's the little chip. Nah, it's still cactus. Memory. Nah, no good. Other memory. No. Nah, there's nothing left. Oh. Nah. Wah. Just for good measure, I'll do the main digital processor, but I don't expect anything because the menu and everything else works, so I don't expect any issue. No, I'll spray the rest of the... No. Rest of the T-con board. No. Caps. No. Converters. No. Nothing. So that, I'm afraid, is a big fat fail. No wonder they tossed the thing out. And there's nothing obvious. The rails check out fine, and no, you shouldn't have to replace the caps. So don't scream, replace the caps, replace the caps. No, the rails, all the rails I can measure seem just fine. Everything seems rock solid. The freezing the T-con board has done absolutely nothing. Reseating some of the connectors and things has done nothing. So, yeah, I don't know. The panel itself, that's all I can come down to. Could still be a fault on the T-con board, of course, but doesn't seem to be any thermal-related solder joint issues under those BGA chips there. So, geez, I don't know. Anyone else got any better ideas? Let me know. That's all I've got for today. So, that was my latest dumpster find. And, unfortunately, it doesn't look like it's going to be a terribly easy repair, but anyway, I hope you enjoyed that, and if you did, please give it a big thumbs up, and as always, if you want to discuss it, jump on over to the EEVblog forum. Catch you next time.